Architecture Student Contest. I'm very happy to be here with all of you to introduce this second session of OneClick LCA training. And also very happy that this topic of carbon is now embedded in the contest task. Thank you, OneClick LCA, for the opportunity to use your tool, your software, and being trained also with these 2-day sessions. As Florent said, all this will be available on the dedicated platform, which is new on this year, dedicated to OneClick LCA partnership with this with our Saint-Gobain Architecture Student Contest. I also just wanted to remind you that all the needed information is available on the Architecture Student Contest website. Of course, the contest task full description in a PDF format, but also in a short video. You'll also be able to have a 360 immersive video of the student contest of the Lisbon plot, where the contest will take place. You'll find also DWG file of the plot, and also the replay of last year's training specific on comfort. You know that comfort is a big part of all the technical parameters which are expected for the student contest, either on indoor air quality, thermal comfort, acoustic comfort, or visual comfort. You have some trainings available as on replay from last year on the student contest website. I insist on all those available elements because I receive lots of questions from teachers or students to have extra information. Normally, there is no need for that. All what you need is already available on the website, and you need to be creative in your project within this framework of the contest task and all the available documentation. So please have a look at it. And of course, I remain available if needed. Thank you again to OneClick LCA for the trainings, and which you do not hesitate to interact and use the chat for any questions.
Well, thank you very much, Eric. So we will continue now with the planning of today. So first, I will remind you how to use the actual Academy site. So the platform that Eric was mentioning. This is new this year. It's the first time we are using that. So basically, you now all have access to the academy.oneclicklca.com. On that page, you will have specific access to a course we have set up. So Saint-Gobain Architecture Student Contest Building LCA Training. And on this course, you will find all information, general information on the course, on the general rules, the access to the software, as well as quite soon some information on the exam and the certification that we will provide. So you have a specific link as well to our help center, where you can see how to access the software quite much more in details. And also you have access to the recordings. So here, for example, for session 1, you find here access to the recording and to the material, the learning content of the session. So that's about the Academy. I will also mention the community page. So quite not so active for the moment. So don't hesitate to ask. I guess the questions will come when we will start using the community, but you are around 230 students who have already subscribed to this page. So please don't hesitate to use the community page for questions, for introductions, for checking the announcement that we will do regarding the training. So it is there for you and for you to help also each other. I will come back to the slides. So last week, last week we covered different topics. It was mostly an introduction to building LCA and also a first software training. So we covered the climate change, why is it important to act now, and why the construction sector is also has to face some responsibility regarding climate change. We also covered what is LCA, the different building stages of a project, from the raw material extraction, if you can remember this diagram showing the raw material extraction, the manufacturing, and then the actual process of building your project with the end of life at the end. How do you dispose of the different materials, and what do you do with your project at its end of life? We also shortly covered legislations and standards, with mentioning that there is a common European framework under which all national regulations and certifications are working. We also introduced the notion of an EPD. An EPD is basically a declaration for a material which showcases the environmental performance of a material. And what you will do when you perform a building LCA is to collect and to model a project by adding the material and selecting their EPDs. And also we showed a demo of the software and how to create your account and access the software. If it's not clear yet, I will also redo a small recall today. So for today's session, we will cover different topics as well. The main goal will be to show you how to reduce emissions in practical projects, and more specifically, how to perform building LCA at very early stage. As architects, you are mostly interested into knowing how you can influence your projects and what kind of decisions you can make quite early in the design process. And this is what we're going to show today. So there will be a demo of our early stage design tool, Carbon Designer 3D. We will show you as well how to optimize a baseline result. So when you have a first baseline design, it's interesting to copy it and to create alternative scenarios to show what can be done to improve the embodied carbon emissions from your projects. And at the end, I will show you how to interpret your results and also how to compare different materials and specify different materials in the software. So let's go directly to the first topic, which will be reducing emissions in practical projects. So reducing embodied carbon emissions in buildings is critical to achieve net zero and carbon neutral construction targets. So you got aware, I guess, of that during your different courses at the university, but also in last week's training. So yet there is much uncertainty about how to reduce embodied carbon. So it's not so clear yet, and it's still quite a new topic for many people. So we will now discuss some of the most effective approaches to reduce, let's say, embodied carbon. And this is extracted from our 10 easy to follow design rules, or commandments that we call, available here under this link. So the first thing to do to improve embodied carbon is to have a baseline building. So let's say a first baseline with which you're going to be able to compare alternative scenarios. So in this case, the baseline buildings in this study that we have done is a 7,000 square meter office building. It has 7 above ground floors of each 1,000 square meters and 2 underground parking levels. It is done in precast concrete frame, and the service life of the building is 60 years. I mentioned last week that 60 years is a very usual lifetime for a building. So basically, we started with 60 years for this baseline. So before we start, it's very important to note that our software does not calculate energy efficiency or energy performance. Our software is an LCA software. So it means that the results in terms of energy usages have to be estimated using other softwares or other methodologies. Nevertheless, it's very important to make sure that your building has a very decent energy performance and whatever low carbon energy supply options your locality can offer. So it's very important to first have in mind the energy performance of the building and what kind of electricity grid you can connect to. It's also important to avoid sites where transport relies on private cars or with long transport distances for users. It will not be the case for you in this case, since the localization of your building is set to the center of Lisboa. But it's always important to remind that even though you try to reduce the carbon footprint of a building, this building is localized somewhere and and has interconnections with the usages of the inhabitants. So if the inhabitants have to take the car, it will also create other carbon emissions outside of the scope of the building. So here are our 10 commandments for embodied carbon reduction. The first one will be designed for 60 years. So basically, we are comparing here a 25 years scenario with a 60 years one. And then the second one will be good soil conditions. The third one, low carbon structural materials. And the fourth one will be specify sustainable products. The fifth one, optimize building shape. I will go in details over all these 10 commandments a little bit later. The sixth one will be reduce floor slab size. The seventh one, reduce parking structures. The eighth one, design for adaptability. The ninth one, limit aesthetic features. And the 10th one, choose long-lived roofing and windows. And you see for each of these commandments, we have estimated the potential, like the maximum potential of embodied carbon reduction. At the end of that, we also combine measures 3 to 10 to see what would be the mostly optimal design, reducing by 43% the carbon emission of this project. So let's start with commandment 1. Do not build for the short term. It might look to be obvious, but if you build a building for 25 years, you will have at the end of life, after 25 years, to replace materials, to demolish, or to send to landfill some materials that are still very valuable. So building for the longer term as possible is one of the most intelligent thing that someone can do. It's like renovation. You keep the structure as long as possible, and maybe you rehabilitate part of the buildings. So this will help you when you look at the impact of replacement materials along the lifetime. This will help you avoid to replace some materials after 40 years, for example, that could have lasted for 60 years. So here in this case, for example, you see that manufacturing the replacement for some material that will last 40 years, this replacement will affect the total carbon footprint of the building, since we will have to remanufacture, to reinstall, and to demolish part of the buildings. So very important to build for the longer term as possible. And the result, this results in very high potential carbon savings, like 40 to 50%. In comparison with the baseline building. So the second commandment would be to avoid sites that are requiring soil stabilization, because deep foundation can mean very high emissions. When you think about foundations, they are mostly done with quite huge amount of materials. These materials are mostly steel or concrete. And these materials are very emissive in terms of carbon, because they are applied in huge quantities. So it's not always, this commandment, it's not always easy for architects, because as architects, you don't really have the ability to influence the site, but you can influence the place on site and the design that you are, the way you are designing the building to reduce probably or possibly the stresses on some part of the soils that would have to be stabilized. So this would be our second commandment, and the potential carbon savings would be about 30%. And then commandment 3, consider structural options. So the big questions is, could a lighter or a timber frame work? If we think about lighter materials, lighter structural materials, I was mentioning last week that structural materials are one of the most carbon intensive when you look at your all carbon emissions and the all carbon footprint of your project. So why is that? Is that so important to consider structural options? If you have, for example, floors or walls that are lighter, it means also less weight on the foundations, thus reducing the size of the foundations and hence also improving for the foundation the carbon footprint. So this is one example, but you can also look, for example, at another material for structural options like timber, for example. So we have here an example of a timber project where we compared wood versus concrete structure, and you see here that the wood options is actually not so intensive. There are different reasons. It's because the process of producing wood materials and transporting is actually less carbon consuming. But in the same time, the wood is a natural bio-natural material, and this means that when the tree grows through photosynthesis, it synthesizes carbon for its own growing process, meaning it can be used as a carbon storage. So which is quite interesting in this case. It has many other dependencies because actually at the end of life, the wood will return the carbon to the atmosphere in a way or in another. If the wood, for example, if a timber beam goes to the landfill, it will eventually rot and emit methane. And if it's burned for electricity, for example, you will also emit CO2 in the atmosphere. So the most interesting thing is to have a forest which is sustainable, which is managed in a sustainable way, so that woods grow afterwards, and also to design the wood structure so that they last as long as possible. So this would in turn result in a potential carbon savings of 30%. So the fourth commandment would be to choose low carbon products. So set clear requirements and select the right suppliers. And I will show you a little bit later in this training session how you can select materials and how you can compare materials in the software. So, for example, here we have many different rebar products. So steel reinforcement for concrete. They are anonymous, but you see here, you can see that there are very different carbon emissions associated with the production of 1 kilogram of steel. It can vary between 0.3 to almost 1 kilogram CO2 equivalent. So it's always important to look for the better efficiency or processes which are requiring less energy, less waste, and less water, and also choosing renewable energy options. So this is what some manufacturers do, and this is why some products are less carbon intensive than the others with the same performance. For example, for concrete, we have here the same the concrete, one example with concrete having the same structural resistance. So it's concrete 4001, 5000 PSI. And you see that a concrete with no recycled cement is emitting way much more, than some concrete having some recycled binders or GGBS or fly ash. So to remind you, just a small reminder if you don't know it, the process of producing concrete is very carbon intensive for two main reasons: because you need to produce clinker, and for that you need a huge amount of energy, electricity, gas, and you also have to crack the molecules of the ore that you are getting from the raw material extractions. You are also emitting naturally CO2 when you are reducing that material. So basically, if you can remove and replace the clinker by other materials like fly ash or GGBS, it will reduce the embodied carbon emissions from your concrete. Another example here for bricks, we have the comparison between a common clay brick and a reclaimed brick, so a brick that is reused from another job site. And you see here that this brick has almost no impact because you only consider the fact that you are getting it from somewhere, transporting it to another job site, and reinstalling the brick for our new job site. And same here for the rebar reinforcement steel that I was mentioning before. So basically, choose low carbon products is very interesting in terms of potential carbon savings. So it can account to a maximum of, for example, 10% in this case for this project. So now we'll look at commandment 5, optimize the building shape to achieve a mass reduction with a compact shape. So as a general rule, a simple shape is more materials and energy efficient. So building in a square shape is not always possible due to daylighting, zoning, functional, or space distribution requirements. But a more complex building shape drives external wall demands and also requires additional access corridors, for example. So if the building requires additional staircase and elevator shafts in different locations, this also creates demand without additional corresponding available room area. So basically your building is a little bit less functional and a little bit less optimized. And this can account to up to 10% of potential carbon savings. So the number 6 would be design thinner floor slabs. So reduce both slab and envelope use. So slabs are a major contributor to the embodied carbon of a building, and unlike the envelope area, the amount of slab scales linearly with the internal area required. So the idea is to reduce once again the quantity of material by keeping the same acoustic, structural, and other performance, fire resistance, for example. And for that, you need to look for different alternatives. So these alternatives should be, for example, having less steel and less concrete. So looking for hollow core slabs or bubble decks or composite structures. And this has to be done according to the other specificities and performances that you require: fire resistance, acoustics, and, for example, structural resistance. So you cannot only count on the carbon for improving your design in this case. This can be up to 6% in the example that we have here of potential carbon savings. The number 7 would be do not build separate parking structures. So apply parking policies to shift demand. So we have, for example, here an example of a customer we worked with a few years back that had a building with 5 floors or 4 floors and 2 underground parkings. And we managed to adapt the design so that they reduced from 2 to 1 underground parkings. And this was also open for helping circulation of air and also removing some retaining walls and some floor slabs. So at the end, we could really optimize the design and reduce by these red lines the quantity of materials. So this really helped to avoid unnecessary carbon emissions from materials. And then commandment 8, use movable or refurbishable wall elements. So this is what we can call design for adaptability. So by doing this, you have a forecast on how the building will be used or could possibly be used according to your needs in the future. So for example, as floor plan configurations may often change, it is good practice to use reusable and possibly movable internal walls to the extent that they work for the building functions. And similarly, electrification that tracks seating arrangements in, for example, office buildings. So these are good practices that you can also put in place in your building. So this can result to up to 4% potential carbon savings. So commandment 9 would be avoid elements with limited value, for example, flooring, ceiling, or facades. So if you have cladding or facade materials and it provides mainly an aesthetic function, we can consider actually omitting this layer. It's the same if your internal ceiling are not providing acoustic or fire protection. The entire element could be removed, and this will also be better maintenance, access to installations and cabling. And the same considerations can apply to flooring. A simple polished concrete floor could be a good option for some types of spaces. So always think to the design in an integrated way without putting any unnecessary element, and then you can reduce a gain of 2, 3, 4% potential carbon savings. And the last commandment would be to choose long-lived solutions for windows and roofing. So this looks quite obvious, and it can be also repeated on different materials. But since windows and roofings are quite carbon-intensive materials, then you can look at them in priority. So basically, when we look at where we were coming from, we had a building that was designed for 25 years with typical concrete structure, heavy foundation, and it accounted for 6,000 tons. By extending, the service life of the building, we could reduce to 4,000 tons of embodied carbon emissions. And then we apply different principles, we combine them, and the measures that I mentioned from 3 to 10 to achieve another 43% carbon reduction. So at the end, you achieve a building with 2,000 tons of CO2, whereas the first building was planned for 6,000 tons. So it's almost 1/3 of what you initially planned in the building. So a quite interesting carbon optimization. So I'm just checking if there are some questions and if recording is launched, which is the case. I see that there was a question here. Hello, as the software doesn't calculate energy, does that mean that it doesn't calculate operational carbon? And my colleagues, Mohammed and Muge, answered, it doesn't calculate the energy, but it takes into account operational carbon. So actually, it's considering energy and water usages. So no worries for that. Okay, I will then continue. So yeah, well, these were our 10 commandments. There are other things that you can put into practice to be sure that you are reducing carbon footprint. For example, incorporate design for disassembly and other circular economy principles into your design. You can buy local materials wherever possible to reduce transport impacts as well. Ensure structural material strength are not generalized but optimized for different uses. Reduce waste and consider the longevity of the materials that you use. And if it needs to be replaced frequently, its impact will be greater. If you are interested in refurbishment, we also have a white paper on low carbon refurbishment, and you will find that on our website in the category resources, where all of our white papers are accessible. So I recommend you to visit this page. So now let's apply these practices in a concrete example. So I will share my screen and specifically the tool. So this is actually the right moment to show you again how to access to the software. So basically, if you haven't done it yet, you can register and activate your account. You just have to go to OneClickLCA.com. You select login in the upper right corner. And if you haven't yet an account, you will have to select new user and register here to fill in your information and to activate your username from the email you received. And then you can be logged in automatically to our platform. I mentioned here that our software is a SaaS software. So it means that this is a software where you don't have to download anything. You can access the material directly online. So the software is accessible online. It's a web-based software. If you haven't received the email, don't worry, it might be that it is in your spam. So please check also your spam folder and check that you have entered the correct email address as well. And now I will come back to the software to show you how to create a project and, for example, how to apply these 10 commandments that I was mentioning before. So this is the interface. So as I will go a little bit faster than last week, since we already went through these different steps last week. So please click on start a free trial or add here and click on enter the license. The license provided is accessible on the platform. This is this one. So this code. As a reminder, the license will be available for 1 year until June 2023 and the end of the contest. So once you have pasted the license key here, you can click on activate the license and the license is automatically recognized. So I will here create a project, which will be called Saint-Gobain Architecture Student Contest Demo. This will be an apartment building since I consider that we will be working on building B, which is a new building, I believe, in your project. I will add here 10,000 square meter and 5 floors. It's informative, but it's good to have some ideas already. So let's say it's good. Let's assume it would be 10,000 square meters and 5 floors. And I will click on next, and it will create my project page where I will be able to get started and click here to create my first design. So I will call this design baseline. It's always a good habit, like I was mentioning last week. So here you have the tool that we are using, Levels Lifecycle Assessment. It's a new construction, and I can thus now click on next. I recommend here to use the default LCA parameters. As I was mentioning in the first session, I went over the different parameters and how they can be set up, but here I recommend to just click on use default parameters. So that's it. We have created our first baseline. So the goal of this manipulation now will be, for example, to apply first typical concrete to the foundations and to just create different alternative scenario where we optimize this foundation. So let's insert some material. I will click on building material. And I go to the foundation category here. And I look for example for a C50. Well, I will clear the filters I have. And I will look here for C50-60, for example. So I will select a very basic concrete with no recycled binders. So C50-55. I select, and let's assume that we have a foundation which is a massive concrete foundation, 500 millimeter thick on 2,000 square meters. We go on the right, everything is okay, and we can just save and continue. So we will have here a first estimation of the carbon footprint for that foundation. It's about 481 tons of CO2. So when I come back, if I come back to the project page, I have here no results because I forgot to add the energy consumption of the building. So I come back to the actual project, and here just as I will assume that the energy consumption is of 0 because I just want to actually analyze the embodied carbon of the foundation. So I will set electricity on 0. I will continue to the calculation period, which I will set on 60 years. And same for the building area, which is 10,000 meters. So just a few times for, so I add 10,000 square meters here. It has been recognized because I inserted that that amount already. And now I save, and I am able to come back to the main project page and to check the result. So basically, now we have a first result. So if we go to element and lifecycle stages, you see that my project is counting for 441 tons of CO2 equivalent, for 480, sorry. And I will now just copy this design, and let's assume that we will look for a less carbon intensive material. So let's click here, for example, on improved GGBS. We will look for a material that, a concrete with the same structural resistance, but with a certain amount of GGBS in it. So here I need to go to building materials. And what I will do is that I will just select this line and try to replace this material directly. So I will click here on replace, and I will look for something with GGBS or fly ash. So I click here in the new material that I want to use for replacing that old one. I click on C50 because I'm looking for a concrete C50, C60. I click here and I see the list of materials I have. So for example, here I have a C50-60 with 30% GGBS in the cement, or 10% or 30% of fly ash. So I will just select that first one, which is quite interesting. And I will click on save, and it will replace automatically the material that I have selected. So if I come back to the main project page, I see that I have already a 36% reduction, and this can be seen here. So my second design, improved GGBS, is already reducing quite a lot the carbon footprint of my foundations. So let's continue. Now that we have selected a more, let's say, less carbon intensive product or low carbon product, let's imagine that in this project, the engineer comes back to you and mentions that actually it would be possible to use just a C30-37. In this case, you want to create an alternative scenario and call it C30-37 GGBS. You can add it, and there I will have to replace the building material that I have with a C30-37. So again, I come back to the software and I go on the right here. I click on change and I click on replace to finally look for a C30-37 that has a significant content of recycled binders as well. So I will click here. I will see that, for example, I can use this C30-37 that has 50% GGBS. So let's use that one and click on save and see what it results in terms of carbon footprint. So I'm coming back to the main page. And I am going to elements and life cycle stages. So here again, you see the final result of your three alternatives with, once again, a nice optimization here by selecting C30-37. And finally, you can imagine that the engineers come back to you and have another way to optimize the foundation by, for example, reducing the amount of concrete, because you have, for example, decided to have structural options that is way lighter, so the concrete foundation can be reduced. So then imagine that you reduce the thickness of the plate. You just go here and you have not anymore 50 centimeters, but 45. And then you save it and you come back to the results. So here you are, you have your 4 design scenarios. with the first baseline, which was a C5060 without recycled binders, and then the optimized version, like in terms of structural engineering, the optimized version C3037, but also with a very low carbon concrete. So actually you are able to here reduce almost to 1/3 of the initial emissions. So this is basically how it is working for applying these principles and these commandments into the software directly. So I will now jump to Carbon Designer 3D. So as I recall, I will mention why we have Carbon Designer 3D and how it is used. So basically, the demo of the concept phase tool Carbon Designer 3D will be done right after. But first, I wanted to recall why is it so important to work so early. So as architects, you understand that every decision that you make at early stage design can influence the rest of the design of your building. And it's not anymore during the specification or the construction of the project that you will be able to make big decisions on the structure, for example, on foundations, on the shape of the building. You cannot do that anymore. The cost of change would be too important, and you don't have the time for doing that anymore. So that's why you need to start as early as possible. And starting early in terms of life cycle assessment is quite difficult because you don't have any information. You don't have the quantity of material, you don't have the geometry, so you don't have drawings, you don't have models to export the data. So it's quite tricky actually to get the information and to perform building LCA early. So that's why at OneClick LCA we decided to create a tool specifically for that. This tool is called Carbon Designer 3D and is intending to help you at the strategic phase of the building. That's where you have the highest impact, and I will show you right after how to use that tool. When you come to the other stages of the design and the planning of your building, you are going to use, for example, Rhino, Grasshopper, Design Builder, or Autodesk Revit. So all these softwares, we have integrations, and I recommend you to check directly on our help centers to see how these integrations are going to work. I will not cover them in details in these sessions because we don't have the time for that. So I will come back now to the software to start with the Carbon Designer 3D demonstration. You will find very easily in your project Carbon Designer, you just have here this icon Carbon Designer 3D. So you click on Levels, Lifecycle Assessment, because this is the tool that we have access to, and it will open a brand new interface. We have launched Carbon Designer 3D this year, so it's connected with your design. So everything that you will be able to do in Carbon Designer 3D at early stage, you will be able as well to import it in the classical app. So sorry for that. So I will continue. Here you just click on Create a Design. I'm expecting it should be launched. Okay, so all information you will need to have a first estimation at the strategic phase of your project, of the planning of your project, is quite small. So you will see that in 5 to 10 minutes you can already have a nice overview of what is possible or not to achieve in terms of embodied carbon for your building. So I will start by creating a new design. It's called Carbon Designer Baseline. Then I need to insert the reference building for this version of our design. Here you see that you have different countries reference building. I will select Italian and South European reference building. So why is it important to do that? It's because Carbon Designer 3D will estimate the quantity of materials, and this quantity of materials in your building is dependent on the habits and the ways that buildings are built, and this is mostly regional. So for example, a German building is not built in the same way as an Italian one. It has different specifications and also different custom and just methodologies of construction. So I would recommend here for the Portuguese project to select Italian and South European building, and then you will have the gross floor area, which I will keep on 10,000 because we assumed it would be 10,000, and also calculation period 60 years. So clicking on next, I will select the building time. It's also very important because it will influence the estimations that the software is going to make. So apartment building. And then define the scope. Well, here I want to select, since I consider we are working on a new building, I want to select all the building parts I want to work with. So foundations, ground slab, structure, enclosure, finishes, and services. The number of above ground floors is 5, and I will assume that I have 1 underground unheated floor. So if you were considering working on a renovation project, for example, here you could decide to let aside foundations and structure and to just perform the Carbon Designer 3D on these resting elements, so ground slab, enclosure, finishes, and services. But in this case, it's a new building, so I want to select every building parts. So now I arrive to the building structure. It's also important to mention what kind of building structure we have so that the software is able to make some assumption. So here we have different possibilities like steel frame, precast concrete, on concrete, cast in situ with maximum column spacing of 7.5 meters. So I will select that option. And for the sake of visualization, I will just add here 10 meters of piling length, but it's only for visualization, so it has no impact on the building itself, on the estimation from the software itself. The 2 other elements that I want to select are second piling wall or soil stabilization. So here, in this case, I will click on second piling wall. Because we, during the excavation, with the removing of the grounds and the earth, we imagine that we need to stabilize the underground, and so we consider second piling walls as well in the project. So let's click on next, and there you see that the software is already. It's still loading. It's already calculating geometry and also showing a first version of the building. Well, it's not the most beautiful one. Anyway, it's the most basic one that the software is coming with. So you see also the different piles here in the foundations. And well, it's coming with some different geometrical characteristics that you can change. So for example, if you move here and you change the depth of the buildings, you can remove that, but then remember to also reduce the quantity because you want to keep the same gross floor area, and you can also make any other change in the geometry of the building. Some other ratio are set and fixed, but in this case, you will not be able to change them, but most of them are, you are able to change them. So now I will also click on calculate areas. And this is the actual calculation of the material quantity. So here you have the quantity of second piling wall, ground slabs, floor slabs, columns, shear walls, and so on. So this is basically, an estimation that you will not have to do, and if you would have had to do it, it would have taken much more time because you had to model your the first model of your building. So here, an information that is important to note is that foundations and also the services, they are based on a ratio on the total gross floor area. So it's like quantity or an impact per square meter. So you don't have to change that, and you have to keep them on 10,000 square meters. So now I will go to the actual calculations. The last thing you need to do is to choose a template that will help the software also specify the quantity. Here in this case, it's a ready-mix concrete column beam frame, 4 to 8 floors, because we chose a building of 5 floors with ready-mix concrete structure. And you click on submit, and as you've seen, it requires like 5 to 10 minutes, not even maybe 5 minutes to perform life cycle assessment by starting from 0. So I will just wait the calculation to be done. So now we are going to the result section of Carbon Designer 3D. So on the left side here, you can look at the result in terms of building elements of foundation, second piling walls. So we see here that the floor slabs are quite heavy in terms of carbon emissions, and then internal walls, heat distribution, electrification. So this is a nice way to rapidly have a view on what is really heavy in terms of carbon emissions. Here by material, you see that the ready-mix concrete, it's quite important. HVAC component, reinforcement for, well, obviously reinforcement because you need steel, rebars in the concrete, and also mortar for masonry. So these 3 materials should be looked at first if you want to first try to reduce something in your project. And here on the right side, you have another view possible, which is called the activate the carbon view, where you see which elements are actually the most carbon intensive. And in this case, we see the floor slabs are really emitting a lot of CO2. So now what I recommend to do is to go down, to click on all element, and to create a copy of this design, which we will call improved CD baseline or CD improved. CD improved. I will create a copy of that, and you will see it will automatically create a second copy of this project, and you can just watch them evolve live by doing some small and minor modifications. So now let's try to reduce the carbon footprint of the floor slabs. Then we will go to the Carbon Designer Improved. We will go on all elements, and there we can just look at the floor slabs, click on Edit Floor Slabs, click on Show Unused Resources, and you see here that you have many different options for floor slabs. Someone was mentioning last week in the training sessions that we, if it was possible, and had a question, if it was possible to model as well CLT structures, so concrete cross-laminated timber, and it's possible, and this is what we will do here. So for the floor slabs, we will replace the concrete cast in situ floor slab assembly with a CLT floor slab, including mineral wool insulation. So what we will do here, we will just set it on 100%. At this stage, I mostly prefer to work with percentages because these quantities are not totally real. So it's better to work with that. And I will set the concrete cast in situ floor slab to 0%. I will wait, and I will see that already I probably get a reduction of my carbon footprint for the floor slab, which is the case, 454 in comparison with 600. So if I click on Finish Editing and I come back to the comparison, I see here that the carbon footprint of the floor slab has been reduced of 200 tons. So quite a nice improvement as well. What we can be looking at as well would be, for example, the internal walls. So let's go to internal walls. Where are they? Internal walls here. So what do we see? We see that the suggestion of the project was to use internal walls assembly for classical for Italy, where we're in Portugal, but it's probably because the reference building was in Italy. So let's remove that autoclave bricks and try to change for another material. So in this case, what could we do? We could look, for example, for inside wall in CLT, for example. So inside wall CLT, and let's see what it does in the software. So let's put back these 90% and check the carbon footprint. Maybe it will help, maybe not. And it's helping quite a lot because we can reduce of half of it. So here I set to 0 the hollow-clay bricks. So I will decide here, for example, to go with an inside wall CLT that is apparently classical in kindergarten and school. So I will click on finish editing and come back to my overall results. And I see here that 2 of the main contributors of the carbon footprint of my building have been reduced of 200 ton of CO2, which is quite interesting. So basically we have here per square meters 424 and 390. So let's say that I'm happy about that design, and actually I want to export it to the main software, to the main app, to continue improving my design later on. So I click on the Carbon Designer Improved, and I click on Save Design to Project. And this will be it for Carbon Designer. I will choose to create a new design, and I will click on Save. I see here questions are coming, so don't hesitate and continue. I see Muge and Mohammed have already answered 2-3 questions, so thank you very much for that. And let's continue working on that. Okay, we have here the main app. We're back in the main app. So what is interesting here is that you see that we keep the 4 first design we had created for optimizing our foundations, but let's assume or imagine that these would be full design. In this case, it's only considering the concrete materials from the foundations, and we have imported as well the quantities from Carbon Designer. So if I click on building materials of the imported Carbon Designer design, I will see that I find back almost all quantities that the software had estimated with the full build-ups of walls, of panels, of floors. So always very interesting. All this job you haven't had to do, and you could do it in almost 5 to 10 minutes. So here I will just go again on energy consumption annual and just set it to 0, because I wanted to set it to 0 just to have a result as fast as possible. Same for building area. Building area I will set to 10,000 meters. And I will click on save. So energy consumption hasn't been saved, so I come back to it. Yes, it's saved, the building area. Okay, it's saved. So I can come back to the main page. And I see here the complete results. So I will go to the carbon view. So here, basically, you see the 4 initial design we assessed for trying to improve our foundations. And here we have a full design imported from Carbon Designer. Obviously, this full design is taking into account all materials and all services for your building for 60 years. So it's not relevant here to compare these designs, but it's just to show you how you can rapidly create design on your own or use Carbon Designer 3D to import very rapidly a design that you think would be more appropriate. So this is about it for Carbon Designer 3D. So I will now come back to the slides and we will go further with the training. Okay, so let me find back my slide. Okay, so optimizing baseline results. I will now show you just rapidly in the slides some ways of performing hotspot analysis. So to spot what are the biggest contributors, you can use what we call the bubble chart. And I will show you right after in the software how it is, how it can be used. Also by showing a classical European project that we have modeled in the software. You can also use the tree map graphs, these column graphs as well, or you can perform a hotspot analysis in Revit. I will not have time to cover the Revit plugin today, and I recommend you to click on this link, which will send you to our help center, which explains how to use Autodesk Revit integration. For that, you will need to download in the Revit store our plugin, and you will be able to directly connect our plugin to your model and to export your model from Revit to OneClick LCA, or even better, to perform it directly the LCA in your model. So please don't hesitate to check that and ask questions on the Academy page if necessary. I will also show you right after how to find better products. For that, I will come back right after to the tool. So basically, you can perform benchmark for products to see if the product you are selecting performs under or above the classical country benchmarks. And you can also compare products by just adding the products to our comparator, and I will show you it right now here. So to compare products, because it's one of the most interesting thing you can do, I will go to another project to show you this. This one. Okay, so how to compare products? For that, you need to click to compare data. And you are opening a new interface, which is our data comparator. You click on edit data, and you will see here the different resources that you have added and that you want to compare with each other. So for example, here I have looked for 2 different glass wool insulation. For doing that, I was setting the, let's say, the filter on glass wool. So I will look for glass wool insulation. I will take the same example as last week. I will look at glass wool insulation from France, and I will look for manufacturer data. So actually EPDs. And here you just have to click on the small arrow to find all materials that are relevant with these filters. The one that I've chosen is one from URSA, is this one, I believe. I'm just checking if it's this one. I think the lambda value is 0.032. So yeah, it's this one, 0.032. And I'm selecting almost the same one from Isofer, so from Saint-Gobain. So I click on these 2, and you see that they are here added with their normal unit, which is the square meter and the same thickness. So you are able actually to compare these 2 materials. So if you have added these materials, you can click on compare data, and you will see here the comparison. And you see here that the Saint-Gobain material is performing 10% better than the glass wool insulation from URSA. So basically, this is how it works. and you can add many more materials to compare. So we can do the exercise for concrete, for example. So let's come back on this compare data page. Click on edit data. And you will see that what we have done a little before with the different alternative designs and for the foundation project, we can do it here as well. So I will decide to delete these two material, and I will look for example for a C5016 here. I will look, for example, for a one like with 0% recycled binder, 1 cubic meter, and same here with C5070 with, let's look for something with 30% GGBS, and we'll look for something having also C5060 but with fly ash, for example. It's kind of interesting. Let's say 30% fly ash. Yeah, let's click on that one. Then you add the unit, so 1 cubic meter. This is the unit you want to compare the products, and you click on compare data, and you will be able to see how these products compare with each other. So the ready mix concrete high stress C5055 with 0% recycled binders and cement, with no surprise, it performs not so good. So basically you are about 450 kilograms CO2 equivalent per cubic meter, and both of the other concretes are performing quite nicely, almost half of the same value with 30% fly ash and 30% GGBS. 30% GGBS is a little bit better, but in the same time, maybe you have difficulties to find it on the market in Lisbon. So why not then start with the 30% fly ash? So this is the example of comparison you can run in the software. So this is how you can compare and select and specify low carbon products. So this, as you recall, this was one of our 10 commandments. And I will now come back to the slides for the last part of the presentation for today, which is interpreting results and other aspects. So basically, there are the main page and the results page. The main page provides a quick overview of the results and allows graphical comparison between designs, and the results page allows further analysis of the results, downloading Excel or Word-based reports or breakdowns based on building elements, classifications, and so on. So on the main page, you have the access to results and benchmarking. So basically what we have done at OneClick LCA, we have collected many different anonymous results from the project of our customer, and we have statistically established a benchmark for embodied carbon. So we are able now to score a project according to if it scores quite well or not, according to other in comparison with other projects. So we have also the embodied carbon by life cycle stage, which shows the impact at every stage of the building. Here, for example, in this case, it's the A1 to A3, so raw material extraction and actual manufacturing of the products. And you can see also embodied carbon by structure, so foundations, vertical element, horizontal. So you can see what part of the structure is the most consuming. On the main page, the unit of results, depending on chosen calculations, for example, in levels, it's in total kilograms CO2 equivalent, and total are shown per design options. So basically, you already got that actually, and I also showed you that on the main page you can be used to compare graphs and allows sorting based on different settings, classifications, and so on. I will go to another project to show you right after. And on the result page, when you want to see results for a specific design and go much more into details and perform hotspot analysis or extract report, you have to click on the actual button, view results, where you will be able to then really go into more detail and also to export, for example, Excel results or Word reports. So this will be the result page. And that's it. We have also the completeness and plausibility checker that I was mentioning last week. I will show it right after because I want to show you, a full page of a full project that has been modeled with levels for EU project. So I will come back. This project is actually that I will mention and show is actually available directly for you as well, because it's a public project. It's called EU Full Building Lifecycle Carbon Study, EN 15978, which is the European standard for building lifecycle assessment. So I will click on that project, and you will see that this project on the main page of the results scores quite badly because it's 762 kilograms CO2 equivalent per square meters. Mostly the embodied carbon is coming from the A1 to A3 life cycle stages, and also from vertical structures and facades and horizontal structures as well. So if I look at the main result here, you see the other decomposition. We have only one design, so it's not very useful to compare here. So I will go directly into the result page. And I will check all elements more into details. So you have here the absolute value of your project, 10,000 tons of CO2 equivalent. It's 13 kilograms CO2 equivalent per square meter per year, which is quite a lot. And it has a social cost of 500,000 euro. It's an assumption that we're making here that every tons of carbons emitted can be associated with the price of the ton of carbon and thus have a social impact in the planet of 500,000 euro, which is here more informative and is not required in any norm, this calculation, since the value of the carbon offset, the carbon ton, sorry, is varying quite a lot. So again, the benchmark, and then you see the results in terms of table. In this project, interestingly, we have wooden material because biogenic carbon has been set. We can check now the completeness and plausibility checker. We see here that some of the check descriptions have not been done. So for example, here, external area mass credible. So we have no material in the external mass area. So it's quite non-plausible, and thus we are here getting a notification that we should look at it. But for example, if we know and if we want to, if we are okay with it, we could here click on validated as well, and then the validated check are here all the ones that are quite credible and plausible and making the calculation almost complete. The most contributing materials are quite interesting as well, since here you can find the lists of the materials that are the most contributive ones. So here, for example, the first one with 1,600 tons is ready-mix concrete without surprise, coming with reinforcement, steel, rebar. So we have here 15% of the impact of the project for this material and 23% for concrete. So concrete and rebar, so basically reinforced concrete, takes almost half of the carbon emissions of this project. So you see here that using classical concrete in a project with classical reinforcement steel can just be very, very, very carbon intensive. And you see the rest here of the different materials. So at the end, we find, for example, 26 tons ceramic tiles and plates, so very, very few actually. So yeah, interesting material and quite light. And then you go to the graphs. In the graphs, you can have the bubble charts, which I was showing in the slides before. You can move it all around and see what are the biggest contributor. So for example, here, HVAC, rebar, ready-mix concrete, and structural steel. Then the Sankey diagram, some tree map as well, which are showing the importance of certain materials in comparison with others. And all of this always classified into different phases. And then the life cycle stages, the annual life cycle stages, always very interesting because you see here that the embodied carbon is actually, well, emitted from phase A1 to A3 mostly. So meaning before the actual end of construction, you have emitted this carbon. And this underlines once again the importance to perform building LCA. Again, you find here other contributions which are mostly the replacement, because in this project there is no energy use, or at least I don't see it in the B6. No, it hasn't been put energy use in this case. So yeah, well, this is what is interesting here, is to see that most part of the emissions are done in the year 0. And then we can continue like materials stacked and yeah, well, classifications with the different elements of the building and how they compare each other in terms of emissions. And then you can find also a recap with all graphs accessible here, and all graphs are actually accessible for download or for download as XLS, so as you want. I can go a little bit further before closing up this training for today by showing how to export the Excel results if you ever need it. It's not so important in your case, but it might be necessary for doing some comparison and having the exact results that you want. You just have to click on download the Excel in this case, and you will have the full result, and you will have to be able to play with these results how you want. So that's it. I will now come back to the training for introducing the homework, or at least the self-assignment. It's not a homework per se, so you will not be evaluated on this. But I can just introduce, this is just recommended for you to do it. It's a self-assignment because it will help you to get the software into your hands and improve your skills in the software. So they're not going to be checked. We do recommend to undertake them, as it complements the knowledge that you will gain during this training. So for this session, we would recommend using Carbon Designer 3D, create a baseline, as I was doing, which represent a typical building in Portugal, and then make a copy of the baseline design and try to reduce carbon emission within Carbon Designer 3D. Then identify the building parts causing most of the impact and change them with better performing constructions. So I have shown you today how to check the results, how to first, how to import design from Carbon Designer 3D, how to check the result, how to improve and compare, and probably, let's say, specify lower carbon products. Then transfer both design into the main OneClick LCA tool, so that I was mentioning just before, and keep applying changes to further reduce carbon emissions. And then look into alternative materials and alternative products. How does local procurement affect the overall impact? How does design for disassembly, so for example, reuse of end-of-life scenario, affect the results? And what is the biggest saving you can achieve compared to the baseline? So all these questions you will have to ask yourself during the architecture student contest. So don't hesitate to just play with it and try already with some projects that you might have to do something. Once again, join the discussion on the community page. I have shown you several times how to access the community page, and thank you very much for your attention. We were a little bit faster today, so I will now take time to answer your questions. I see here that there are only 2 questions. One of them I've already mentioned was already answered, and the second one is, in the calculations, are there any key assumptions to keep in mind when doing scenarios? For example, some materials are missing EPDs, energy mix of the country, and Müge has already answered. It's important to choose the closest material. If not exist, it is good to follow regional generic data. So yes, exactly. You don't always have the opportunity to have the exact material from the exact manufacturer you want. In this case, you will have to select the closest regional generic data that is provided by the software. So this is your role to assess that and to choose it, unless you are importing the design from Carbon Designer 3D, and in this case you have already pre-selected materials. Another question, is it possible to generate a building with empty spaces, holes in the building blocks in Carbon Designer programs? This is a good question. I don't see any answers, so I guess the answer was not so clear to find as well. Currently, the shape of the building is quite basic in Carbon Designer 3D, so you cannot, let's say, perform so easily empty spaces, I would say, or at least I haven't had any experience with that. So I would say quite difficult, but what I would do is to make a rule of thumb and try to evaluate the ratio of spaces and just remove it from the actual quantity that you have in the building, for example, from the floors, from the roofs, and maybe from the foundations as well. Because if you have holes or, let's say, patios in a building, then you remove actually a quantity of this building, but you add more glazing and windows. So you can also start by using Carbon Designer, import your design from Carbon Designer, and then once you are in the main app, you remove the quantity from the holes that you are intending to model. I don't see any other open questions yet, so I will wait a few more minutes to see if it's not coming. It's the right time to ask your questions, so don't hesitate. We're here for helping you on that. And if there are no other questions, we will then close the session, sorry, for today. And I will upload the recording. So if you have some friends or colleagues working on these topics or participating with you, you can then share with them the recordings. And by the way, the recording of the first session is already available. I think I mentioned that already. So if there are no other questions, we'll wait 1 minute more. Maybe if you think about it. I see already people leaving, so well, if there are no other questions, I will thank you very much for your attention and for the participation into these 2 sessions. We are very delighted and happy to be partner of this training, and we would like, well, very much to thank you for your participation and wish you good luck as well for the student contest. And I'm sure we'll be in touch in the future on the community page if you have some extra questions. So good luck for that, and see you very soon. Thank you very much.